There was a time when every respectable high street had three things: a butcher, a baker, and a buzzing neon sign trying its best to electrocute the rain. Above the chemist, the cafe, the kebab shop, and the off-license, great glowing tubes of glass were being fed by transformers kicking out thousands of volts, which was fine right up until the building caught fire and someone arrived with a hose pipe capable of turning electricity into a very short career choice. So, outside the shop, usually next to the sign, you'd find a big red switch, the Fireman switch. Its job was simple: kill the power to the sign before the fire service gave the building a thorough rinse. Then the world changed, neon started disappearing, LEDs arrived, signs became safer, cooler, and far less likely to hum like an angry fridge. The fire service quite rightly stopped being a men-only club, and somewhere between the 15th and 18th editions of the wiring regulations, the old fireman switch became the firefighter's switch. A small change in wording, but a big nod to the real world, and for a while it looked like these switches were fading into history. Another relic of the neon age, heading for the same dusty shelf as rewirable fuses, brown bakelite and electricians smoking in consumer unit cupboards. But here's the twist: they didn't disappear, because in regulation world where nothing ever truly dies, the firefighter switch is still very much alive. And in fact, in the newly printed BS7671 Amendment 4, the requirements for a firefighter switch take up a good half page, starting at Regulation 537.4. The old requirements are still there, doing what they've always done. They still apply to discharge lighting installations inside or outside a building operating at more than 1000 volts, unless that is the equipment is rated at less than 100 watts and plugged into a nearby accessible socket outlet. So don't worry, if someone treats you to a neon bar sign for your kitchen, you won't suddenly have to bolt a firefighter switch to the front of your house and invite the local fire authority round for a cup of tea. But there's another clause that changes the conversation. Regulation 537.4.2 says a firefighter's switch shall be provided in the low voltage circuit, supplying specific equipment in certain premises, subject to the requirements of the fire authority or subject to licensing conditions. Specific equipment in certain premises, and that's where it gets uncomfortable, because certain premises isn't a list you can check off and file. It's not a clause you can point to and say doesn't apply here. It's a judgment call, one that doesn't belong to you. It belongs to the fire authority, to the licensing officer, to the insurer who writes the conditions before the policy is issued. You can complete a job to BS7671. You can do everything right by the book, and then a fire authority inspection happens, or a premises license renewal comes around and a firefighter switch is required. Not suggested, required. And if it wasn't in the original specification, that's not the fire authority's problem. It's not the building owner's problem. It's yours. This is why the conversation is changing, because the equipment that Regulation 537.4.2 is increasingly being applied to isn't neon signs. It's the systems now appearing on rooftops, in plant rooms, in underground car parks, and behind the scenes in buildings where emergency isolation matters enormously. Solar PV arrays, battery energy storage systems, EV charging infrastructure. Think about an underground car park fitted with a bank of EV chargers. There's a fire, the fire service arrives and needs to kill the power to the charging equipment before they can work safely. Where do they go? What do they switch off? How quickly can they find it? If the answer is I'm not sure, that's too late. Increasingly, fire authorities and insurers are specifying firefighter switches for exactly these scenarios. Not because BS7671 hands them a precise list, but because the regulation gives them the authority to require one, and they're using it. In previous editions, petrol filling stations were specifically mentioned, which made perfect sense. If a forecourt catches fire, you probably don't want someone wandering over to operate the pumps while simultaneously filming the fire service on a smartphone. That specific mention may no longer be there, but in the real world, you'd still expect to see firefighter switches installed wherever the risk demands it, and that list of locations is getting longer. So let's look at what a correctly installed firefighter switch actually looks like, because there's one detail that catches people out almost every time, and it's right on the front of the unit, and this one we've got hold of is from CPN Cudis. And although at first glance it may look like a regular isolator that's been given a red jacket and a sense of drama, there are some important differences. Firefighter switches have their own product requirements. They can be manufactured to BSEN 60669-2-6, or they can sit within the isolator standard BSEN 60947-3. But the most obvious difference is the operating handle. This is designed so it can be operated using a pole, because in an emergency, the person switching it off may not be standing neatly in front of it with dry hands, clean boots, and a laminated method statement. They may be outside in smoke, in rain, using a proper operating pole, or in the real world, possibly a sweeping brush. And because of that, the off position is upwards, which feels completely wrong if you're used to normal switches, but makes perfect sense once you think about how it is operated. When you're pushing up with a pole from ground level, it's generally easier and more controlled than trying to hook something and pull it down. Once operated, the switch latches in the off position, so it can't simply be flicked back on by accident, by vibration, or by someone wandering past and thinking, oh, I wonder what this big red thing does. To restore power, the spring latch has to be deliberately automatically release before the switch can be returned to the on position. And the location matters too. The regulations specify that the switch should be installed no higher than 2.75 meters from the ground, high enough that it's less likely to be casually operated by someone passing by, but low enough that the fire service can operate it quickly and easily with a pole when they arrive. The markings matter as well. The words on and off along with fire switch or firefighter switch need to be clearly legible with letters at least 10 millimeters high, which is one of those beautifully practical requirements, because if a building is on fire, visibility is poor, people are moving quickly, and nobody wants to play a tiny font guessing game on the front of a red box. The switch we've installed here is a 4-pole version rated at 63 amps. Now, in reality, a lot of firefighter switches probably won't be carrying the full load directly. Many will be linked to contactors, shunt trips, or control circuit inputs, where the red switch is the visible emergency command point rather than the muscle doing all the heavy lifting. And as you'd expect for something living outside on the side of a building, this unit is IP65 rated, so it's built to deal with rain, dust, and the general misery buffet of British weather. There are also plenty of cable entry options, which is handy because these things rarely get installed in perfect textbook conditions. They get fitted where the building, the cable route, the equipment, and the emergency access point all grudgingly agree to meet. We'll leave a link in the description where you can check out the full specification. The location of the firefighter switch matters as well. Firefighter switches are either installed close to the equipment they're isolating or in what the regulations describe as a conspicuous location, which in real world speak means don't hide it behind a bin store, above a suspended ceiling, inside a locked cleaner's cupboard, or round the back of the building next to the pipe that always drips on your neck. It needs to be somewhere obvious, somewhere the fire service can find quickly, somewhere that makes sense when people arrive under pressure, in the dark, in smoke, in bad weather, or with half the site shouting different versions of the truth. And if the switch is remote from the equipment it controls, the signage has to do the joining up. A notice needs to be displayed near the equipment stating where the firefighter switch is located. And next to the firefighter switch, there needs to be a notice saying which part of the installation it controls, because a big red switch with no explanation is not a safety feature. It's a building size guessing game. So if the switch is isolating a solar PV rapid shutdown system, battery storage equipment, and EV charging installation, discharge lighting, or any other specific equipment, that needs to be clear. At the equipment, the notice tells you where to go. At the switch, the notice tells you what you're about to turn off, which is exactly what you want in an emergency. No treasure hunt, no cryptic labeling, no "I think Dave knows where that goes." So the firefighter switch may look like a simple red box, but unlike a lot of equipment, the consequences of getting it wrong don't show up during installation. They show up when the fire service arrives and can't find the isolation point, when the licensing inspector adds a condition that should have been in your spec from day one, when the insurer writes a clause into the policy that nobody flagged at design stage. The regulation is deliberately wide, the responsibility isn't. Know the premises, know the systems, know when to ask the question before someone else asks it for you, because a big red switch in the right place can save a building, and the absence of one in the wrong premises can cost someone a great deal more than a callback. So where have you been asked to install one? Solar PV, battery storage, EV charging, commercial kitchens, petrol forecourts? Drop it in the comments, because if the range of answers is as wide as the regulation suggests, that's a conversation worth having. Now, one thing that keeps coming up in the comments whenever fire safety and electrical systems share the same conversation, and it came up again while we were putting this video together, is surge protection, specifically type 3 surge protection on fire alarm circuits, because it turns out that fitting a firefighter switch correctly is only half the story. What's happening upstream of that fire alarm panel is a conversation a lot of installations are quietly getting wrong. We're going to be exploring that in a video coming up very soon. So if you're not already subscribed, now would be a good time to sort that out, because that's exactly the kind of thing you don't want to miss when it lands on a job you're already standing on.